Good Easter, people. Was wondering if I actually had a video for you guys today, because I've been testing something I was not that's been irritating me. When you print with different speeds, I noticed that these test patterns that go down in the build plate when you print with a Bambu printer, sometimes they are fast and sometimes they are slow. If you write with the stock profile for a Bambu filament, with stock speeds and everything, is like gone, done, finished. I usually print with a specific profile. Let me see. I'm gonna show you guys. This. I usually print this profile here, and in this profile I have really low speeds because it's silk filament and it's extremely small details. So I run this at 20 ms, sorry, and when I do when it does the printing of the pattern, it's like super slow, and that takes like 4 minutes of the print time. Annoying, yes. So I've been testing like all these values here, which one could affect it. So I have confirmed it's not first layer infill. It's not the travel speed. Like I tried to change it to 400. I tried to check small parameters. I tried each of the infills. I tried the top surface. I tried the gap infill. I even tried the bridges. Nothing really seemed to work. So I thought, okay, I need to check the G code. And so I went into the nozzle settings, because I thought I checked the settings of the filament and there was nothing there. And this changes when you change the nozzles from a 0.4 to a 0.2. It changes dramatically. So I went in here and the machine code, and I started reading this, line by line. I started scrolling down, and kind of far down I came, like it's like I read, and you see it's like, you see these sections here, like prepare, print, temperature, and material, blah blah blah. It's like it prepares to extrude, etc. And all of these is like it's synonymously with the preview. When you do a preview, you get this list of G code happening, but it's easier to read it in here. So I just scroll down, and it's like wipe nozzle. I know when that is happening during the test. So it's after this, and then I'm just scrolling down to show you guys. Wipe nozzle end. So now it's finished with the nozzle. Check scanner clarity. Bed leveling. Either it will, if you untick bed leveling, it will just do a LiDAR scan instead, a little bit faster. And then bed leveling end. Home after wipe mouth. Okay, so it will wipe the mouth. And then it will home into the corner. Turn on vibration suppression, turn on fans to prevent PLA jamming. All that is fine. And then you get to this nozzle load line, and I thought, okay, doesn't really, it's like it's drawing lines. Okay, maybe that was it. So I just scrolled slower here, and I found, okay, move to starting position. It does that. It moves to the top left corner of the printer, and it waits there. And then I found this outer wall volumetric speed 0.3 times 0.5. Actually, it's volumetric speed divided by, and then parenthesis 0.3 times 0.5. And those are then multiplied by 60. And this could explain why the speed is slowing down. So I tested this. So keep this in mind. I'm just going to show you a test now where I do a quick jump to the part where it will print with the normal settings. So I'll just go back to the test model. These are totally stock settings I'm using now. So I have sliced the profile. It looks like this, and all I want to do is print it. Let's see what's on the build. There's nothing there. So print it, and I'm just gonna pause the recording. See, I'm turn off bed leveling, time lapse, and flow dynamics because I don't need it for the test, and it makes the test go faster. So I'm gonna pause the recording and show you when it starts with a timer. Okay, so now it just did a LiDAR scan, and now it is waiting. So I'll bring up the timer and be ready to click it the second it starts to go. So this is stock settings of 0 to nozzle, and how long it takes for it to draw the line. Then it goes a little bit to the left and it goes back to the line. So I will stop it when it comes all the way to the back. So there, that is pretty much exactly 40 seconds with the stock settings, as you can see. And now I'm going to do the same test with my settings, and you will see how long it takes. By the way, if you wonder what this is actually a free timer you can get inside the Microsoft store. It's just called free timer. So it's nice. It's just a small pop-up. Okay, so I'll see you in a bit. So I am going to change the value to what I use, 20 for the outer wall, 20 ms, and I'm gonna slice it again, and I'm going to print the plate, same settings. And I'll just time skip to the LiDAR. So now it's LiDARing again. Then it draws back, and I'm gonna reset the timer. And I'm gonna push it when it starts. As you can already tell, it's a lot slower. So while I was waiting for this to finish its post-processing, I was thinking I'm going to try and change the machine code, because if you try to adjust this using your print settings, then you sort of suffer your own print. But this speed is based off your print settings with a certain calculation. So if you change those calculations instead, theoretically you could print with your speed for the print itself, but this test print thingy could be faster. So I'm going to test that afterwards by changing the values of the machine code. So it's not even finished with the first line, so we're already at 54 seconds. One minute. Coming out on 1 minute 30 seconds. One minute and 51 seconds that took. So I brought the machine code into Notepad++, and then we can find the line called nozzle load line, which is a section we are gonna modify, and we're gonna try with two things here. I'm gonna try and lower the value first, and I'll only lower the 60 value because that's the one that will sort of change the speed. The other ones will be constant. What you haven't seen is there is a shitload of these in the code, so you need to use something like Notepad++ to change all the settings. And hopefully all of them are equal. Some of them are probably not. So let's see how many. Is there two? One. Let's do a check. I'll replace the star by 60, and actually we can just change the 60 exclamation mark. That's easier because it closes the bracket. There. So you just use the find tool and you just replace 60 bracket with, let's say I want to try 20, just for a test, and then replace all. There's 113 occurrences, and I'm just gonna check that all of these were changed, that there is no longer anyone with 60. You see, I'll just search for this. Find next. Looks like all of those has been changed correctly, and the code goes all the way to the bottom. Even here you see it changed it, so it looks okay. Okay, so that is 20 now instead of 60. So I'll take that back. I'll wipe the old code and I'll input the new one, and I'll save it as 20. Test pattern. Okay. It's just so you know that's the one with the 20, and I'll close it. And we are using the 21. And then I'll revert the speed. Actually, you saw the quick speed before, so I'll leave it at 20 like it was, and we'll see if it goes up or down based on that, because that's the last measurement we did. So I'll slice it again, and then I'll print the plate and do a time skip. So it's doing its slider again. This is the time we need to beat. Let's bring up another clock. Get ready to start. Looks almost like it's going slower. Like a lot slower. So maybe if you lower from 60 to 20, for instance, you are lowering the equation and making it slower. I would hate for mathematics that is like, oh, you need to increase it to make it slower. That would be bad, because it's more logical if you can reduce the value to make it slower. 30 seconds and we're not halfway. And remember, we came up to a minute for the line to be completed on the first one. It's roughly halfway, coming up on a minute. One minute, still not at the end. One and a half, still not at the end. So I think that is the value. So if you know your filament can handle the speed on the test prints, I would recommend you set that value maybe to, instead of for your 0.2 nozzle, maybe set it to 150, or 3 times the speed you normally have, like not 60 but 180, and then that should probably make it go like normal speed or something. But because you would normally, with the 0.2 nozzle, you would normally print slower than with the 0.4. So we're up to 2 minutes and almost 30 seconds, and it's almost finished with the first line. And now the video will be long, but I will just let it finish so you can actually see how long it takes. The way it's handling now is how it feels like when I print. I know it's not, but it still feels like that. I guess you can just fast forward the video from here a couple of minutes, because this is most likely gonna take almost 6 minutes. And it's going and going and going. So you can just move this down to here for now. Accidentally clicked stop there, but it's just for a split second. Given how slow it is, it doesn't really matter much. record. I said 6 minutes roughly, and it's still not at the end. There. So roughly 5 minutes and 30 seconds roughly. So now I'm gonna go and change the value. Let's see here. So I'll just change this. Replace with 180. Replace all. There should be 113. Earlier I replaced 113. Now there is 111. So I need to just check to the code. Let's see if I can find something was labeled wrong here. Here is an X20. Okay, so there is an X20 there. So that please. $115. Let's see. I just scroll from the bottom and up. There are some values like this. I don't think I'll bother to change that because it's mostly the other ones you would be after. Could probably change this as well, but I think I'll leave it just for simplicity. Okay, so I'll bring that code in. You can see here that in the machine code now it's 180, which is a lot faster than the 20 we used. Let's save that as 180. Go back. And then I'll do a slice Print it. And I'll do a time skip. So LiDAR is going again. So let's get ready. Ten seconds, and it's at the end. Can it beat the 40 seconds here, which is what we had with standard settings? 29. You can do it. "38 seconds. So by changing that threefold up, when you go down, it actually makes it possible to extrude faster, even though you are printing at low speed. So the actual printed speed set now for outer wall is 20, and the speed I used for the test pattern is roughly the same as the standard one. So basically, if you're tired of waiting for the test patterns when you change your outer wall speed, then just change your machine code and you're all set to go with faster print times. I hope this helped you, and thanks for watching, and I'll see you in the next one. Oh, like and subscribe.